In Unit 9, we're going to talk about circles. In our first lesson, we want to talk about the equation of a circle in center radius form. So there's going to be two ways that we define circles, and center radius form is probably the easiest one, so that's the one we're going to do first. On the coordinates below, sketch a circle with a center at the origin and a radius of 5 units. So whenever we go to sketch a circle, we need 5 points. We need the center point, which in this case at the origin. And then if our radius is 5, that means we're going to go left, right, up, down, 5 units from that center. So from the center, we're going to go left 5, back to the center, we'll go up 5, back to the center, we go right 5, and back to the center, we go down 5. All right, and again, this is just a sketch. So as best you can, you want to try to connect those points, obviously not with straight lines because it's a circle. So you want to make it as circular as possible. Okay, so it's just to name 4 points that lie on the circumference of the circle as sketched below, or sketched above, excuse me. So obviously, unless your curves are perfect, none of those points are going to really be exact. But the reason we went left, right, up, down is that gives us 4 points. So the first one we went to, when we went 5 left, we had negative 5, 0. When we went up 5, we had 0, 5. When we went right 5, we had 5, 0. And when we went down 5, we had 0, negative 5. Okay, so those 4 points are definitely on the circle. Now it wants us to plot the point 3, 4. Using your sketch above, do you think point A will lie on the circumference of the circle? Now, you can see that it doesn't exactly line up on mine, but you'll also see that there's not much curvature realistically to that part of the circle for me. So because it's a sketch, it's a little bit hard to tell, but I'm going to go out and I'm going to say yes, that I think that point is going to lie in the circle if I had a better sketch of my circle. All right. How can we prove this? Well, if we look at how we can actually prove this, everything in, or a lot of the stuff in circles, especially with the equations, are based off of Pythagorean theorem. Okay, and Pythagorean theorem for circles is really easy when your center is the origin. All right, so if that point 3, 4 were to be on the circle, then we should be able to do x squared plus y squared equals, and then if you think about it, this really makes a right triangle here with our x, our y, and then what's going to represent our hypotenuse? Our radius. All right, so it should be equals r squared. Okay, so x squared was 3, y squared was 4, and r squared, we know our radius was 5. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. Since 25 is equal to 25, then yes, 3, 4 is on the circle. All right, so starting to figure things out is really based upon Pythagorean theorem when we're dealing with equations of our circles. So exercise 1, on the grid below, a circle centered at the origin with a radius of 10 is partially drawn. What is true about every point that lies on the circle? Well, if you remember, every point that lies on the circle is equidistant from the center, because every point that lies on the circle has the same radius. So all points are equidistant from the center. Okay, and what does that really represent? That represents our radius. Okay, so show that the point 6, 8 is on the circle. So just like we did in the last one, we're going to use our Pythagorean theorem. So 6 squared plus 8 squared should be equal to our radius squared, which they told us here was 10. 6 squared is 36. 8 squared is 64. 10 squared is 100. 36 plus 64 is 100. So 100 equals 100. So that checks out, and 6, 8 would be on our circle. Is the point 4, 9 on the circle? Why or why not? Well, we're going to do the same process here. So 4 squared plus 9 squared equals 10 squared. 4 squared is 16. 9 squared is 81. 10 squared is still 100. 16 and 81 gives us 97. So that does not work out. So if we were to explain why or why not, the point 49 is not 10 units from the origin. All right, remember, every point on the circle should be the radius distance away from the center. And since the center here was the origin and the radius was 10, 49 is not 10 units from the origin. So like we've used Pythagorean theorem so far to figure out if a point lies on a circle, we can come up with just a general equation for a circle. And now be careful, because this is the one that's centered at the origin only. All right, it's x squared plus y squared equals r squared that we've used a couple of times. All right, so this, again, be careful. This is only the equation of the circle that is centered at the origin. So if we look at exercise 2, the point 5, negative 12 lies on the circle centered at the origin. Determine the equation of the circle and state the radius. So if they told us one of the points on the circle, we can find our radius using our formula, and then we can figure out what our equation is. So 5 squared plus negative 12 squared equals r squared. 5 squared is 25. Negative 12 squared is 144. Remember, whenever you square something, you automatically get a positive. 25 and 144 is 169. Square both sides, and you get a radius of 13. Okay, so now if we want to write the equation of this circle, whenever you write your equation, the x squared and the y squared always stay. And then for the radius, you have two options. You could write 13 squared, so actually write what the radius squared is, and you'll see that's the way that I prefer to do it most of the time. But this is also the same thing. So since the formula is set equal to r squared, you could actually square that 13 and get 169. These are technically the same exact thing. You just have to be careful if you are working with the bottom one. All right. Use the equation from part A to see if the point negative 314 lies on the circle. So negative 3 squared plus 14 squared equals 13 squared. Now, as I look at this, the fact that there's a 14 squared on the other side and it's equal to 13 squared, I'm going to venture a guess that the answer is probably no, but let's do the math just to make sure. So negative 3 squared is 9, 14 squared 196, 13 squared 169. Add these together, you get 205. 205 definitely does not equal 169. So the answer is no. Negative 314 is not on our circle. So unfortunately, not all circles are going to be centered at the origin. In all honesty, this is what you are going to probably deal with most of the time. The formula for these circles is similar and can be found using the distance formula. So consider a circle centered at the point 3, 2 with a radius of 6. Sketch the circle described and mark an arbitrary point on the circle as xy. So if we were to draw an xy axis here, we're centered at the point 3, 2. So 3, 2, so there's our center. So now we basically need to get 6 above, 6 to the right, 6 below, and 6 to the left. And then we're going to do our best to sketch our circle. All right. Now, it wants us to pick a point anywhere on the circle to be xy, just so that we keep everything nice and easy. I'm going to pick that point right there, and I'm going to call it xy. All right. So we know that this point is 3, 2, because that's our center. So if we connect those 2 points, what does that form? that forms our radius, which we don't know. Oh, we know has a length of 6. All right. So now what we're going to do is use the distance formula to determine the equation of this circle. So if you look at this radius line here, which again we know is 6, the distance of that line is equal to 6. So now if we want to use our distance formula, remember we are d equals big square root x2 minus x1 squared plus y2 minus y1 squared. So what are our 2 points going to be for this circle? Well, the first point is 3, 2, because that's our center. And our second point is the random point xy that we picked. So as we make our big square root here, x minus 3 squared plus y minus 2 squared is going to be equal to 6. So the left side represents the distance between those 2 points, and we know that should be equal to 6 because that is our radius. Now this is almost what our equation of the circle is. We just want to get rid of the radical. So what's the opposite of taking the square root? It's squaring something. Well, whatever you do to one side, you got to do the other. So now on the left side, we end up with just what is underneath. And then on the right side, you could keep it as 6 squared, or you could actually do 6 squared and make it 36. But right here, this is the equation of our circle for something that is centered at a point other than the origin. Okay, now we set that up through the distance formula to show where it came from. But as we work with these, we are not going to use the distance formula. We're going to kind of commit to our memory what the equation of a circle not centered at the origin actually is. And that's right here. So x minus h squared plus y minus k squared equals r squared. So h and k are the center of your circle, and r is your radius. I would also like to point out to you the minus signs. So we kind of dealt with this in our point slope formula, where you remember the opposite sign is what you end up using because the formula had minus signs in it. It's kind of the same thing here. All right, so for exercise 4, what we want to do is we want to use the equation of the circle to determine the center and then the radius in simplest radical form if we have to. So for all these problems, I'm going to write c equals and r equals. So let's go with our center first. If it just says x squared, if you just have a letter squared, that means the center part of that coordinate is a 0. And then if it says y minus 1 squared, well, again, I told you to watch out because the formula has minus signs in it. You are always going to take the opposite sign. So the center is going to be 0 comma positive 1. And then the radius is the square root of 81, which is 9. Okay, so the radius is not the number that you see. That number has been squared. So you have to take the square root of it to find the radius. As we go down here to b, x minus 4 squared plus y minus 3 squared equals 1. So c equals r equals. So remember, there's no zeros in this one because they both have parentheses and they both have minus signs. So we're going to take the opposite. So we get positive 4 and positive 3. And then our radius is the square root of 1, which in this case just happens to be 1. As we go up to part C, we have center and radius. So again, we have to take the opposite sign. So if we see x plus 5, our center is going to be negative 5. And then the y is by itself, so that's going to be a 0. And then the radius is the square root of 40. Well, 40 is not perfect, but 40 splits. Square root 4, square root 10 gives us 2 square root 10. Right? And we don't have to worry about plus minus in this piece because it's a distance, so it has to be positive. And then the last one. So our center, we have x plus 1, so negative 1, and y minus 6, so positive 6. And then, not the diameter, the radius is going to be the square root of 72. So just like we did before, 72 splits. Square root 36, square root 2 comes back together to give us 6 square root 2. Okay, so you can see here by working with the centers, you're always taking your opposite signs, and if there's ever a letter by itself, it's a 0. And then you have to take the square root of what you see there for your radius because it's already been squared. So here's one that's a little bit trickier. The endpoints of the diameter of a circle are 2, 6 and 10, 12. Determine the equation of the circle. So there's always two things you need for the equation of a circle. You need a center, and then you need a radius. All right. So I'd like everybody to do is pause the video for a second and come up with a plan for solving for this equation for their circle. All right. So if we need a center, we need a radius. For our center, okay, if you have the endpoints of your diameter, the midpoint of the diameter is your center. Okay, so that's how you're going to find your center coordinate here. Now for your radius, you have two options. Okay, you could find the diameter, distance, and then divide it by 2. Or after you get the center, so after you do your midpoint to find the center, then distance, the center, and one endpoint. Okay, and you can pick whichever one you would like. But once you find your center, the distance between that center point and one of those endpoints, A or B, would be your radius. Okay, it's kind of up to you. You have to do a distance formula either way. All right, so now if we're going to find our center here, remember our midpoint is the average of the x's and the average of the y's. So 2 plus, so 1/2 of 2 plus 10. Well, 2 plus 10 is 12, and half of that is 6. And then our y midpoint is half of 6 plus 12. Well, 6 plus 12 is 18, and half of that is 9. So our center point is going to be 6, 9. Now for our radius, I think it's easiest to just do the distance between the diameter and cut it in half. So 10 minus 2 squared plus 12 minus 6 squared equals, so I go to my calculator here, I am 10 minus 2 squared plus 12 minus 6 squared. That's going to give me 100, which is really, really nice. So I get square root of 100. So I get 10. Now remember, that is your diameter distance. Okay, so then your radius is going to be 5. It's going to be half of that diameter. So as we go to write our equation here, I'm going to write down what the formula is again. So x minus h squared plus y minus k squared equals r squared. So our center was 6 and 9, so that's h and k. And then our radius was 5. So now as we go to write our equation here, we are going to be x minus 6 squared plus y minus 9 squared equals, and again, I like to keep it as 5 squared, but you could also keep it as 25. It's kind of up to you, all right? But that would be the process that you would follow to find the equation of your circle if you're given 2 endpoints of your diameter. And the last one here is determine the equation of the circle graph below. Well, the first thing we need to do is we need to basically draw a diameter for the circle. So you could draw the vertical one or horizontal one. I would not draw any of the diagonal ones. So we have a diameter here of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we know we have a radius of 5. Well, in that case, then, we know we have to count 5 units to get to our center. So 1, 2, 3, 4, 5. So there's our center point. What's its coordinates? Well, there's our origin. So 1, 2, 3, -2. So we have a center at 3, -2. So if we want to write this equation, will be x minus 3 squared plus, now be careful, it's y minus negative 2, so it will be y plus 2 squared equals, and again, make sure you're using your radius, not your diameter, so you're going to end up with 5 squared. And that's all our work for our equation of a circle in center radius form.